Okay. Here we go. So today we're going to get into a bit of a difficult topic, okay? So if you're used to kind of just like, paying half attention to me and you're okay with how you do, I would really encourage you to not pay half attention today. Give me 3/4 or something like that. But you're going to need to do more here because this new topic, this is brand new. Okay, this is brand new. I don't think you guys have ever heard of logarithms before. Oh, okay, maybe you have, maybe in transitional algebra or something like that. I don't know, but okay, we're gonna be talking about logarithms today. Okay, and it just causes some students some confusion. Okay, so definitely make sure you tune in. They are not going to go away. These are going to be like the primary way that we solve exponential equations. Okay, but Mr. Widmeyer, we just spent all Friday solving exponential equations, and they didn't use logarithms. You're right, but these are all special cases where the exponential equations, they were able to be written as the same base. But what if we don't have the same base, right? What do we do? So we're going to use these things called logarithms. And yes, logarithms exist on your calculator. I'm not going to show you how to use them today, though, because I want you to really wrestle with the concept yourself first. All right, so we're going to start out, though, with something fairly straightforward as far as, writing equations thing. Actually, I'm going to switch to blue here because I think this marker is about to die. Okay, so sorry if this bothers you that I'm going to switch from black to blue. All right, anyway. What's the solution to this equation? It's not a trick question. What's the solution to this equation? X must be what for this equation to be true? What number? 3. Okay, that's right. 2 to the third, okay, is 8. Let's try another one. 3 to the x equals 9. What does x need to be here? Not 3, careful. 2. Okay, 3 squared is 9. All right, and how about then this equation? What power of 3 is 4? 3 to what power gives us 4? 3 squared? Yeah, 3 squared would give us 9. Maya? It's going to be a decimal, right, okay. Can you tell me, between what two whole numbers it'll be? 1 and 2, very good. Yes, if you look here, folks, right, if we say, okay, well, let's say what's 3 to the 1. 3 to the 1, that's 3, right? 3 to the 2, well, that's 9, okay? 4 is between 3 and 9, right? 4 is between 3 and 9, so we'd expect then whatever this x value is to be between 1 and 2. So yes, it's going to be some decimal. And so what logarithms are going to allow us to do, logarithms are going to allow us to solve equations like this, okay, where we don't have a nice whole number, okay, that our x value works out to be, or even a rational number, right, because we do have fractions we work with, right, like number 2 there in the warm-up was 10/3 for your answer. All right, so we're going to introduce this new idea that will allow us to help us solve these kind of equations. That is the logarithm. Okay. And the logarithm is the inverse of exponentials. Okay. So in math, right, you've learned this, you've been learning math since elementary school, right? And typically, whenever we introduce one kind of idea, we also kind of introduce its opposite too, right? Or its, what kind of, its opposite, I guess we'll say, right? So for example, you first learned addition, but not very long after the operation of addition, you also learned about what? Subtraction, right? And then multiplication, right? Not long after you learned about multiplication, you then learned about division, right? And then as you progressed, right, you learned about more complex things, right? You learned about squaring, right? And then what cancels out a square? You eventually learned about square roots, right? And then you learned about cubing things at some point too, and then you learned about cube roots and all that stuff, right? So we just talked about exponentials, right? Expressions or equations that have the variable in the exponent, right? And we want to cancel those out. Well, we're going to use logarithms. We're going to use logarithms to undo or to cancel out those exponentials, okay? So how do we use logarithms? Well, let's say we've got some generic exponential equation here. Y equals a to the x. Okay? We're going to call this exponential form because, well, there's a variable in the exponent there. Our x is in the exponent. right? And a could be, you know, any number you want there. Well, any, you know, like 3, 4, whatever kind of thing. Okay? Well, it turns out that this exponential form has an equivalent form in logarithms, okay? To rewrite this in logarithmic form, we take the base of our exponent here. What is the base of this exponential equation? It's base what? A. Okay, so we're going to write log, okay, and like logarithm, short for logarithm, right? We just use log, though, short for logarithm. Log base A, so that A is like a subscript. Okay, it's like a little bit lower, just like when you square something, that square is like higher up on the line. This is like a little bit lower on the line, right? So you can imagine like if you were thinking about like handwriting paper. You guys remember that? Back in like elementary school, you had paper that looked like this, right? Yeah, maybe. And then you write, okay, log, and then the A would go like down here. Okay? You remember that? Maybe not. Bad memories? Okay. Cursive on those? Okay, yeah, so like that, right? Yeah. If you don't use it, you lose it, you know. I hate cursive. It wasn't even a thing? Oh. Why is cursive important? Except for signing things, that's all. Yeah. Mm-hmm. So log base A, it's supposed to help you write faster too, I think. If you write in cursive, you write faster. I don't know about that, though. Mine's really sloppy, so anyway. Unless I take my time. But then it's like, well, that defeats the purpose. Anyway. So log base A of y equals x. This is the equivalent logarithmic form of what we just wrote up here. So these two things are equal. Okay? When I say y equals a to x, or when I say x equals log base a of y, these are saying the exact same thing. Okay? I wrote it in English there too. X equals log base a of y. So you really think about this y as like inside the logarithm there. It's log base a of y. So the y is kind of inside the logarithm. Okay? So how are we going to do math with it? Well, today, for right now, we're just going to worry about like evaluating logarithmic expressions. Okay? Today we're just going to focus on evaluating logarithmic expressions, and eventually we'll start incorporating them into equations. All right, so let's just say our directions here are to evaluate. Or in other words, maybe you could say simplify as well. Okay? So, first example, log base 2 of 8. Okay? So you could be walking around, right? And then you would see a log base 2 of 8. You'd be asked to simplify it. Okay? Doing your student kind of things, and then you'll come across a problem like this, and like you need to be able to simplify log base 2 of 8, or what does it mean? What does it equal to? Okay? Anyone want to take a guess what log base 2 of 8 is? Or not a guess, but maybe you think you know what it is? It's a value. What value would it be? What's that? 64. Anyone else? No idea? What do you say, Kobe? Not sure? That's fine. That's fine. Okay, we're just learning it right now, right? So here's what I'm going to say to you right now. Because we're just learning this, like eventually, I hope you get to the point where you can look at this and just give me what the answer is. Eventually, I would like to get to that point, right? Just like eventually, or at one point, when you saw something like this, you maybe had to think, okay, square root of 4, what times itself gives me 4? And now when you look at this, you'd see, oh, square root of 4, that's equal to 2, right? But in the past, maybe you had to think about, okay, what squared gives me 4, right? You had to think about it more. Well, the same thing here, right? You're going to look at this now. We just learned this, right? So you may not know how to do it right now. Eventually, I hope you will. How are we going to simplify this? Well, I don't know what it equals, right? Kobe's like, I don't know what it is. So let's just say it's equal to some unknown number x. Let's just say it's equal to x. I'm going to put this in. I'm adding in this equals x here. Okay, and now what I'm going to do, I'm going to rewrite this. I'm going to take my logarithm that I've got. I'm going to rewrite it in equivalent exponential form. Okay? So to rewrite my logarithm in exponential form, well, let's first identify the base. What is the base of my logarithm? It's base what? 2. The base of my exponent then is going to also be 2. Okay? Now notice how things move around here though. The number that's inside the logarithm, notice where it goes. Y, right? Y moved to the other side of the equal sign by itself. So the 8, which is inside the logarithm, is also going to move to the other side of the equal sign by itself. So we'll have equals 8 over here. Okay? And then where does this x go? It goes to the exponent of our base. Right? So it'll be 2 to the x equals 8. That is our equation that we want to solve. Or this little bit of work here will allow us to find the value of our logarithm. Okay? Questions on that? It is super crucial that you are able to rewrite from this logarithmic form to this exponential form, okay? At least for now. Okay? So the base of the logarithm becomes the base of the exponent. The x switches sides over and becomes the exponent of the base there, and then 8 also switches over to the other side as well. Okay? And so what is our answer here? 2 to what gives you 8? Well, it's 3. Okay? 2 to the third power gives you 3. Okay? So in other words, log base 2 of 8 is equal to 3. Okay, 3 is our answer here. 3 is our answer. So when you see a logarithm, right, when you see this logarithm, the question you can ask yourself to answer it, 2 to what power is 8? Okay? 2 to what power is 8? That would be the words that you would ask yourself, or you'd say to yourself, to help you answer this logarithm without having to actually do any, sort of like rewriting if you don't want to have to rewrite. Okay? 2 is the base, so 2 to what power gives us 8? That's 3 in this case. Okay? All right, let's try another one here. Or another, I have several actually we're going to try. Question? I will tell you to do that later. Right now I want you to be able to do it in your head. But I know, Isaiah. I'll show you how to do it in the calculator eventually. Okay? But I want us to really be able to get comfortable with just doing it in our head, because really this is like mental math, right? It's like your teacher didn't teach you how to do 2 plus 2 and then just hand you a calculator and say, okay, now just use it on the calculator, right? Your teacher had you do a bunch of addition over and over again, so that way, you kind of get the hang of what the operation is doing here, okay? Otherwise, if I just give you the calculator, it's just going to be mathemagic to you. Okay? So, log base 3 of 81. Or in other words, 3 to what power gives us 81? Okay? 4? We all agree with that? 3 to the 4th is 81? That's right, yeah. So the answer here is 4. That's right. Okay? Next one, log base 2 of 16. Or in other words, 2 to what power gives us 16? 2 to the 4th. So 4 is the answer again. Not very original, Mr. Widmeyer. Let's try another one. Log base 6 of 36. 6 to what power gives us 36? To the 2. Okay? See? Don't need a calculator for these, right? You just have to ask yourself the right question. Okay? Let's try some more here. I'll make them a little bit trickier now. Log base 3 of 1. In other words, 3 to what power gives you 1? I heard it. 0. It's 0. Good job. It's 0. Okay. 3 to the 0 is 1. Log base 25 of 5. 25 to what power gives you 5? 25 to what power gives you 5? It's going to be a fraction. Not 1/5, nope. 1/5 is if you were like multiplying. We're doing exponents here. 25 to what power gives you 5? What's that? Not 1/3, nope. You're getting closer though. 1/2. It's 1/2. Yep. The square root of 25 is 5, right? So that's 25 to the 1/2 power. So 1/2. Yep. Okay. If at any point you're like, Mr. Widmeyer, I don't understand here. If at any point you feel lost, right? You can take this logarithm that you're trying to find. Okay, let's set it equal to a number x that we don't know, right? Rewrite it in exponential form. So 25 is our base. X becomes the exponent, and then it's equal to 5. Okay, Mr. Widmeyer, how are you supposed to solve this? Get a common base. 25 is 5 to the 2. Okay, that's 5 to the 1. 2 times x is 2x. Right? And then just drop your base. You have 2x equals 1. And so x is 1/2. Whoa. Okay, you have x is 1/2 then. Okay? So don't fret if you get stuck or lost, okay? Use the exponential equation skills we just learned and use that to help you, okay? I'll show you how to use a calculator eventually, though, how to do this. Okay. How about log base 3 of 1/3? Or in other words, 3 to what power gives you 1/3? 3 to what power is the same as 1/3? -1? Yeah. -1. 3 to the -1. 3 to the -1 gives you 1/3. So the answer is -1. Good job. All right, one more here together. We'll look at some properties then. One more here together. How about log base x of x to the 5th? Log base x of x to the 5th. And we'll assume here that x is not, well, I guess, let's see here. I think you have to say like x is greater than 0 and x is not equal to 1. That's just, again, a stipulation. But anyway, log base x of x to the 5th. What power of x gives us x to the 5th? 5, yeah. Interesting. Questions on these problems? Questions? Okay. Again, it's really, this is the key question you want to be able to ask yourself. Okay? You know, log base 2 of 8 or log base b of a, right? You can just think in generic terms. So if you have something like, you know, log base b of a, it is b to what power equals a. Okay, this is the crucial question that you need to be able to answer and know to ask when you're evaluating a logarithm. Okay, any random logarithm you come across, log base b of a, b, your base, to what power equals a. That power that you come up with, that number you come up, that's your answer. That's your answer. Okay. All right, we're going to look at 2 logarithms that are so special they have names, and then we will also then look at 3 basic properties, and I'll give you guys 3 problems to try, and we're done. Okay. So any questions so far? Super important you get down this fundamental idea. Okay, logarithms are going to be very difficult if you don't get this first. So any questions? I can re-explain anything too. We're all good? Okay. All right. So then, let me show you 2 special logarithms that are named. Okay, these are buttons on your calculator, so we're getting closer to me showing you how to use your calculator to do it, but I'm not going to quite do it just yet. Okay. Log base 10 of something is the same as saying log of something. Okay? So in other words, if you come across a logarithm that has no base written, we don't assume it's base 1, we assume it's base 10. Okay? So when you see a logarithm with no base written, it's base 10. This is known as the common log. Okay, common log. common, I think, just because, you know, we're used to, our number system is base 10, right? You go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 in the ones digit, and then once you pass 9, you create a 1 in the tens digit, and then you go 0 through 9 again in the ones digit, and then you put a 2, and so on and so forth. Keep going. Okay, it's base 10, right? Probably because we have 10 fingers. It's kind of crazy to think about, right? That we probably have a base 10 number system because we have 10 fingers. Most of us, right? Anyway, that's the common log. So if you come across a problem like this, log of 100, okay, we understand that is really log base 10 of 100. And what is the answer to this? 10 to what power gives us 100? 2 to the 2. So the answer is 2 there. Okay. This is something you can type in your calculator, Isaiah. So for example, if you see the log button on your calculator, if you type in log and then 100 and hit enter, you'll get 2. Okay. So if you happen to come across any of these on your homework with no base, then you can of course use the log button if you want to. Okay, and I'll show you how to do other bases another time, not right now. All right. The other named logarithm is the natural log. And it is the logarithm with base of e, the number e. Okay? E is like pi's less famous cousin. It's like pi is Alec Baldwin and E is like Billy Baldwin. You know, they're both famous, but everyone loves pi, and no one really pays attention to E. Okay? So, anyway, I don't know if there's a better reference for you guys, but E is a number that's like pi. It's irrational. It's like 2.718, and then it goes on forever, never repeats. But again, no one really bothers to memorize digits of E. Everyone's all excited about pi. And E doesn't really have its own day like pi does, even though I guess you could celebrate it on February 7th. Maybe. I don't know. Anyway. It's just no one loves it as much for no reason, I guess. But E is, it has to do with exponential growth or decay. Okay, it's a constant that's used sometimes for those. Okay. So anyway, the logarithm you'll see here, you'll never see a logarithm like this. You'll never see log base E of x like that. What you will see, okay, you'll actually see ln of x like that. Okay, that's for the natural log. Natural log of x there for you. Okay. Now, why isn't it NL? Because we say natural log, right? Well, that's because actually, I guess it's from the French, logarithm naturel. Okay. I'm not even going to bother trying to do a French accent there. It's going to be embarrassing for me. Okay. So, but logarithm naturel is where it comes from. So really natural log. And we'll do some work with those too, eventually here. And the ln button is also on your calculator. I think it's right below the log button. Yes, it is. Okay. So there's log, there's ln, right? And you can see second ln gives you the e to the x command, and second log gives you 10 to the x command. So, all right. 3 basic properties. We're going to look at more advanced properties tomorrow or the day after. But for right now, we'll establish these 3 basic properties here. Number 1. Okay. So in general here, and this is for a greater than 0 and a not equal to 1. Okay. A greater than 0, a not equal to 1. Here we go. Basic property number 1. So as long as a is bigger than 0 and not 1, log base a of 1 will always be what? Log base a of 1 will always be 0. Because remember, what is this asking? A to what power gives us 1? The only way you can take a, raise it to an exponent, and get 1 is if you have a power of 0. Okay, so that's a basic property right there. Basic property number 2. log base A of A. What will that always equal? Well, what's log base 2 of 2? Or in other words, 2 to what power gives us 2? 1. What's log base 3 of 3? 3 to what power gives us 3? Log base 4 of 4. Log base 100 of 100. Log base A of A, 1. So you take the log base of itself, and you get 1. All right, last basic property here. Log base A of A to the x. Okay. Now I'm being even more generic here, right? Even more generic. A to what power gives us A to the x? A to what power gives us A to the x? X. Yeah. Again, what is this saying? This is really like saying A to what power equals A to the x. Well, the only thing that can fill in that question mark there is an x, right? That's it. So it's got to be x. So those are our 3 basic properties right there. Okay. Log base A of 1. A to what power gives us 1? 0. A to what power gives us A? A to the first. And then A to what power gives us A to the x? X. Okay, so here's 3 for y'all to try. Okay. 3 for y'all to try. Number 1, please tell me what log base 4 of 64 equals. Number 2, please tell me what log base 2 of 1 is equal to. Hint, that is one of our basic properties. You can use the basic properties to help you there. And then number 3, log base 3 of 1 over 9. Okay, what does that equal? And for all of these, you can use that, rewriting it as, A to what power gives us the number, kind of thing. The base to what power gives us the number. All right, so go ahead, take like a minute and answer those questions. I'll come around and check on things here. Which one are you trying to read? It's log base 2 of 1. Log base 3 of 190. That is the babiest little analogy model I've ever seen. I mean, that's the smallest analogy I've ever seen. Yeah, I mean, so whatever. Yes, that's exactly right. So you're right. You're saying this is saying 2 to the 1/2 power gives me 1. So, well, you tell me. 2 to the 1/2 equals 1. Remember, 1/2 exponent, that's the same thing as saying like square root of 2. Is that true? No. So that's not true. So 2 to what power is equal to 1 there?
2 to the 1/2, you're like saying 2 times 1.
2 to the 1/2 is a square root. 2 to the 1 is a square root of 2 to the 1.
So number 3 is probably not going to be that.
So, okay. You're right, it's not. Because, again, 3 to the 1/3 is what you're saying the answer is 1/3, right?
Oh, yeah, that's right.
So 3 to the 1/3, that's the cube root of 3, which does not equal 1/9. Okay. Again, you're trying to think 3 to what power gives me 1 over 9? 3 to what power gives me 1 over 9? Yep. So you're saying 2 to the power of 2 gives you 1. That's what. So the power is what your answer is. So 2 to what power gives you 1? 2 to 2. 2 to what power gives you 1? what exponent of 2 gives you an answer of 1?
So that is the answer to this one. Should it be x?
Which one?
When you say number 2, is it log base 2?
Of 1, okay, equals, you said x.
Yeah.
So, if I were to rewrite that, so that's a good starting point. Yes, Isaiah, that's a good starting point. Can you see okay?
Yeah.
Okay. You wrote this, right?
Yeah.
Okay. So, I'm going to read, because again, I want an actual value. Your final answer should be a value here for these, okay? So, I'm going to rewrite this in exponential form. 2 is the base of my exponent, 2 is the base of my logarithm, so it becomes the base of my exponent. Okay? X becomes my power, and then it's equal to the 1. Okay? So setting it equal to x is helpful. Now you got to figure out though what number goes in for x here. So when I do 2 to that number, I get 1. 2 to what gives you 1? Okay, that's what you're trying to answer. Anyone else need some help?
Oh, 1 to 0?
Yes, I say exactly right. I'll give you like one more minute. You know. So 3 to what gives you 1 over 9? 3 to what power gives you 1 over 9?
Oh, 3 and -2.
All right, well, now let's go over this since we've kind of discussed the answers already a little bit here. All right, number 1, what's our answer? 3. Number 2, what's our answer? 0. Number 3, what's our answer? -2 is the answer there. Okay. So let me talk through number 3 at least here. Okay, so we've got log base 3 of 1/9. We want to know what that equals. Let me just zoom in here too, that'll help. Okay. Log base 3 of 1/9. So we're going to set that, I'm going to set that equal to, I don't know what it equals, I'll just set it equal to x. And now I'm going to rewrite it in exponential form. Okay, so 3 becomes the base of my exponent. X is now going to become the power of that exponent, and then I'm equal to 1/9. Okay, now, how do we normally solve an exponential equation? What are we looking for? A common, what? Common base, okay? 1 is a power of 3. 1 is 3 to the 0. 9 is also power of 3. 9 is 3 to the what? Nope. Careful, yeah, 3 squared. Okay? When you divide, what do you do with your exponents? Subtract. So what does x have to be? It's got to be -2, right? X and -2, so it's got to be -2. Okay, and there's your answer. Okay, you can do a similar thing here for number 2 as well, where again you write log base 2 of 1 equals x, and you rewrite it 2 to the x equals 1, and so 2 to the x equals 2 to the 0, right? Because 1 is the same thing as 2 to the 0, and aha, x is 0, and there you go. Okay, you can do a similar thing with number 2, and you can do a similar thing with number 1 as well if you really want to, where you can just realize that log base 4 of 64 is just 3. Okay? Questions on any of that? Okay, no questions there? All right, let me show you then what your homework is going to be.